Four data points are plotted at right. The least square regression line and the equation of the least square regression line are also shown. Point D is at 414. What is the residual of D? So let's take a look at this. Given a lot of information here, but one of the important things is I want to write down right now is this point D, x is 4 and y is 14. So when x is 4, right, the actual value for that point D is 14. So I know I've got the actual, I'll just label this A, the actual value is 14. The predicted value is somewhere here, right? So this is what the curve, the model is saying that y should be when x is 4. So what we need to do is figure out exactly what is this predicted value, and we have a very nice mechanism for doing that, and that's this model, right? So this model says you give me x and I'll predict what y should be. So let's go ahead and take this, and I'm just going to enter, whoops, I'll just enter 1.54 times the number 4, and then I'm just going to add to that 6.46. So here you can see I've got my slope of 1.54. I'm multiplying by 4, and then I'm adding 6.46. And when I press enter, I get that that should be 12.62. So this is my predicted value, 12.62. Well, at this point, we know the actual value, and we also know the value that's predicted by the model, so I can figure out the residual. The residual is that difference between the actual and predicted. So my residual in this case, the residual should equal the actual value of 14 minus the predicted value of 12.62, and you guessed it, here's the calculator again. So I'm going to take 14 and I'm going to subtract. I could just jump up and grab that. 14 minus 12.62, and I get that that is a difference of 1.38. So notice it is positive, right? Because we do know D should have a positive residual. It's clearly above the model. So we know the answer is 1.38, and this residual is in the units of the whatever the y-axis units are, but I don't know what those units are, so I'm just going to leave it without units here.